28?
I did 28.
So remember that, so when somebody asks, we'll have that answer.
What is the date on it?
With this, what we're going to do with this, we could go down through and solve this, and I'm going to solve it right here just real quickly. You guys help me through it. What's the first thing we do to start to solve this? Distribute. And when I distribute here, I get 6x plus 12, is that right? Plus 26 minus x on the other side. Then we can collect like terms on this side. 6x plus 12 stays the same. Just have to sort of fight the fact that I'm writing over top of other stuff. What's 5x and negative x give us? Good. 4x plus 26. Now what do I do? Here's where a lot of you, it's not wrong the way that a lot of you do it, but it just seems to confuse you. Subtract 4x. Get all the x's together first. What is 6x minus 4x? Those cancel out. You're left with 26. Now what? Minus 12. Good. Those cancel out. Leaves you with 2x equals, what's 26 minus 12? Then what? Divide by 2. I'm running out of space down there. What's that leave us with? That's the way you did it last year. Now, at the start of last year, when you were starting to solve equations, you should have talked about some properties. And what geometry is a lot of is you can't just do something and not give a reason for it. All right? You got to give reasons for things. And what we're going to start today, Mr. Brockman's favorite. I'm just kidding, it's everybody's favorite. If you've ever talked to a student who's taken geometry before, this is what they love the most. We're going to start what's called a two-column proof. And it's called a two-column proof. Anybody have a good guess why? It's got two columns. It's that simple. It's called a two-column proof because it's got two columns. In a two-column proof, you have a column for statements, you have a column for reasons. Sort of like an outline. What it does, it shows Raven, Colin's doing a problem, and he hands it to Raven. She should be able to go down through his statements and reasons and figure out how to do the problem. It's like an explanation, like directions to how to do the problem. Each statement's got a number, so we're going to number each statement. Number 1, that statement's always going to be matched up to a reason, so if we number that number 1, this over here is going to be numbered number 1, so that they match up. Sort of like maybe an outline. In English class, you're writing a paper. First thing you should do is write a outline, right? I know that doesn't happen a lot of times. A lot of times you jump right in and start trying to write it. Does that ever happen, Devin? You just start trying to write it. Oh crap, I forgot. Got this paper due tomorrow. And you start writing it. Should always write an outline because it helps you to get your thoughts, gather your thoughts. What we're going to do here, the first statement, hardest one of all of them. Might not be able to read mine completely because I just wrote it. Where'd I get that from? That was the original equation, right? How did we know that that equation was true? How did we know, forget that we solved it, how did we know that that equation was a true equation? Quit worrying about solving it. When you first looked at that, and I said, solve this equation, you didn't go, what equation? How'd you know that was an equation? I gave it to you, didn't I? That's what you write right here. Given. First one's easy. First statement and reason's pretty easy. Just write, how'd I know this? It was given to us. Then what you do in the two-column proof, you don't show all this work like you did in or an algebra class, you don't show the work, you just put the next step. So how did I go from here to not how did I go? Notice I went from here to there. That's what I'm going to write next. 6x plus 12 equals 4x plus 26. What did I do? Skip a step there somewhere? Yeah, that one. Now, here's where everybody starts to have trouble. You got to give a reason for why you did that. You know it in your head because you knew what to do. You just don't know how to write it out on paper. So you got to be able to explain yourself on the paper. How did I go from number 1 here to number 2? What mathematical rule or property or whatever did I use? Distributive property, and that's what I write right here. Distributive, I'm going to abbreviate, property. No, Sam, if you misspell that, it's marked wrong. You think I checked spelling? Do I look like I put that much effort into grading this? Probably not. Number 3, we went from here, subtracted 4x on both sides, and we ended up with this. This is what we want. We don't want to put the minus 4x on each side. We're not showing our work here. We're just putting in the next step. So 2x plus 12 equals 26. How did I go from number 2 here to number 3? What did I do? Sort of. I subtracted what? Subtracted 4x on both sides, right? And what we're going to learn today is when you subtract x or subtract something on both sides of an equation, this is what it's called. Subtraction, property of equality. That's an equal sign, not a z. Subtraction, property of equality. How come it's not just called subtraction property? What's subtraction property tell you to do? Just subtract. Subtraction property of equality tells you you do it to both sides of the equation. That's where the of equality comes in. What did we go to after we had 2x plus 12 equals 26? 2x equals 14. Now we got to give a reason. How did we go from this to that? What did we do? We subtracted 12 on both sides. Guess what you're going to write right here then? Subtraction property of equality. Now, I'm going to abbreviate a lot, but can I abbreviate subtraction, SUB? And the reason is, there's another property that you learned last year that could also be abbreviated SUB. Does anybody remember it? If not, we'll talk about it here in a little while. So when you do subtraction, at least go out that far. Because I can tell SUBTR is subtraction.
You get all that big, must have tried it all.
Yeah, that's what I write subtract usually, because it doesn't make sense to me not to go ahead and put those extra 3 letters on there just to be sure. So subtract property of equality. Where did we go after we had 2x equals 14? So you came up with what? X equals 7. How did I go from 4 to 5? You divide it. Now, give me the reason we're going to write down there. Think about these two that we just did. So you're not just going to write division.
Is it division property of?
Division property of equality. Division, and then this one I'm going to abbreviate. Division property of equality. What's our next step going to be? What was the next step in algebra? That was it, wasn't it? That's it on this 2-column proof. If this 2-column proof was on a test, it'd be worth 10 points. Anybody have a guess where I get the 10 points from? 5 plus 5, 1 point each. So you get this point. Should anybody miss the first one here? That number 1 there is your reason. 99.99% of the time is going to be given. You got to start off with something you're given, and then you work from there. All right? So you should get those 2 points just about every time. The rest of them, I'm hoping on these algebra ones especially you understand it, but just in case. All right, set that off to the side. In your books, page 80. Page 80. The homework. Questions on page 80, problems you want to see work about patterns and the different stuff. Huh? Michael's not allowed to ask questions anymore. Rough night, Joe? Looks like you're wore out. He's hurting? Yeah. You got a messed up finger? Good play tonight? I'll take care of him, Joe, don't worry. Me and you are not. Quit making rude comments. Hey. Questions? None? Everybody understands all the patterns?
16.
20? 20?
40.
40. Couldn't hear you. Gotta speak loud, I'm getting old. Problem 40. I'll do 16 next. Remind me.
Okay, thank you.
Problem 40. The following are the first 9 Fibonacci numbers. Somebody help me out and read me those numbers.
1, 2, 3.
21 what?
34.
Anybody pick up what's the pattern doing there? That's true. Give me a little more. A lot of things go up. All right, so you add the 2 previous numbers to get the next number. Add the 2 previous numbers to get the next number. What's part A ask us? I think that's what it asks us, isn't it? What is the pattern?
Make a conjecture about each of the Fibonacci numbers after.
So add 2 to get next number. Is that a conjecture? Yeah. Part B says
Write the next 3 numbers in the pattern.
write the next 3 numbers. I think all we did was A and B, right? I said forget, don't do C. So we want to write the next 2 numbers. Is that what I said? Or 3? 3. Next 3. Take those 2 numbers. What do we get? 55. Then you're going to take the 34 and the 55. What do you get? 89. Then you're going to take the 55 and the 89. What do you get? 144. Next one. You said which one? 16. 16 says find a counterexample to show that the conjecture is true. Remember with the counterexample. If I write this down on 16, because as soon as I start off the sentence that way, what do you know?
Mark wrong.
That's wrong. A counterexample is supposed to be what? One specific example. Just an example that shows that it's false. Not an explanation of why it's false, not anything else. One specific example that shows that it's false. It says line S divides segment MN into 2 line segments so that line S is a segment bisector of MN. So So they're giving us this, and they're saying that this is always correct. So I'm going to draw segment MN. Where am I going to draw line S at to show a counter example? Am I going to put it right here? You want to put it somewhere where it doesn't split it into two congruent segments, right? So, would that work?
Yeah.
Well, how am I going to name this line S? Does S go right there?
No.
Where does S go? Remember, if it's a lowercase, it goes out there on the arrow, and we're going to go over some more of this today. If it's a lowercase, it goes out there on the arrow. It doesn't actually represent a point. So that would be our counter example. Next question. Joe, you're going to have to go down and tell them, knock it off. Noise. Either learn to play better or knock it off.
Well,
Woodwork.
That tells me where Brandon spends all his time instead of doing my geometry stuff. All right, go ahead and start copying this down. These are your notes for today. We're going to do 2 assignments today. That's why I'm hurrying. We're doing 2. One of them we're going to do right here in class. You're going to see. Just try to be nice. And you laugh at it. It's like you guys aren't used to somebody actually doing nice things. It's not that much, but
Thank you.
I put my phone on silent real quick.
check it and see who texted you. It's McKenna.
Yep.
Is it?
Yeah, this is Kip and Milton.
Alright, I was gonna say, if it's McKenna, give me the phone, I'll text her back and tell her to knock it off.
That'd be funny, actually. Yeah, what would be?
I did that the other day in intervention, didn't I?
Who would?
One of the seniors that I have in class, somebody was texting her during intervention.
Which sent?
Yep. Nice. It was probably, I don't know who was texting her, I'm guessing it was Braden. Texting back, knock it off, she's trying to learn.
What did he say?
I don't know. I don't even, it just confused him. Last year, somebody from CTC was texting somebody in my last block class, and I took their phone, texting back, and he texted me back this.
What the freak?
And I had to text him back and say, "This is Mr. Eversole, and you better watch what you reply back with when you are doing stuff like that."
What did he say to that?
He didn't say anything after that. He didn't text back. Might be Mr. Alexander. He's got his own, like a wooden flute. He plays it, but Alexander. But maybe he's teaching somebody else how to play. All right, well, we're going to cover postulates and diagrams. We're going to go back over some of the diagrams that we were drawing. Some of you had trouble with it on the test. Got to know how to draw these different diagrams when they're explaining them to you. Be able to understand and use postulates. Let's go back over postulates. I think we did this last time. Give me 2 other terms that we put right together with postulates. Other ones. The same as postulates. Thought we talked about this last time. Axioms and corollaries. And I probably spelled that wrong. I don't know. different every time I spell it. Doesn't matter. Those are all the same. Now, Shelby said theorems. Theorems and postulates, sort of the same, but a little different. And that's what we want to talk about right now. What's the definition of a postulate? What? Just give me a couple words.
Isn't it proven?
That's it.
No, it's taken for granted.
All right, so we just take this, it's just taken to be true. And a theorem, when we start talking about them again, theorem, what do we know about a theorem? Is it just taken to be true? That's got to be proven. It's got to be proven true. So postulates taken for granted to be true, theorems proven true. We're going to sketch and interpret diagrams, use algebraic properties, some of those properties we just talked about, to write proofs, and we're going to actually write 2-column proofs. Somebody open up their books. There's a page. It's probably like page 84, 85. I don't know. Somebody's got to help me out here.
I got it right here.
Got it? There's a yellow box. Is there a yellow box? It's got all the postulates in it. Do not, when you write this down, don't go by the numbers. This book calls this postulate 2.1. If you go back in my back room and grab a different geometry book, it's going to call this postulate 1.5. Some other book might call it 3.2. Doesn't matter. Those numbers don't go with them. So what I want you to do, Peyton, help me out. Each time we get to one of these, give me the title. What's the title for this postulate that the book gives it?
Alright, so that one's 2-point postulate.
2-point postulate. So write this down, skip a little space. We're going to draw a picture with each one of these. That first one's called the 2-point postulate. Raven's going, oh my God, we went over this all earlier this year. And she is exactly right. If I tell you you got 2 points, what do you know? It makes exactly one line. All this stuff that we're going over now, we went over in chapter 1. It's just, they're actually putting it in formal form now with a postulate. So I got point A and point B there. In our world, this doesn't count Colin's world, this is our world. We're not going into the Twilight Zone or anything. In our world, how many lines are there in our world that contain those 2 points? Exactly one. That's the only line in the world that contains those 2 points A and B that I have there. There's no other line. So any 2 points make exactly one line. If we turn it around and I start with a line, how many points is it going to contain? At least 2. So anywhere on this, I could pick a point there and a point there. And those 2 points are going to be on that line, and that's the only line that they're both going to be on.
Is that title 2-point postulate?
Oh yeah, I'm sorry. What was the title of the second?
Line point postulate.
Line point postulate. Thank you, Shelby. Line point postulate. This one, a lot more important than the reverse or the converse of it. All that making sense, John? Easy stuff, isn't it? Through any 2 points, there's exactly one line. The way I'll usually say it is 2 points make a line. Everybody ready? What was that? Didn't look good. What's the next one called?
Line intersection postulate.
Line intersection postulate. Just from the name, anybody tell me while I'm writing this down? What do you think it's going to say? Quit reading it out of the book.
Intersections.
The intersections of what?
Postulate.
But probably lines, right? We talked earlier this year, I got these 2 lines, they intersect. How they intersect? Well, they intersect at? 1 point, exactly 1 point. That's what the postulate says. Got 2 lines, they're going to intersect at 1 point. Now if I take these 2 lines and I do it a different way, now they intersect at 2 points, right? No, it's impossible. Alright? I do it this way, now they intersect at 3 points, right? No, they intersect at 1 point, no matter what. So 2 lines, if you have 2 lines, then their intersection's exactly 1 point. Draw my line here. Somebody name that line for me. How would you write that? Line T. On the test, a lot of you are doing something like this, using the little letter and putting the symbol with it. Can't do that. If you got the little letter that's out here on the arrow, it's got to be the word line T. The only time you use the symbol is when you have 2 letters, like line AB, and they're capital letters. We got another line. We got this red line. Somebody name that line for me. Line B. Black line, the red line, they intersect at exactly 1 point. And we're going to call that point H. 2 lines intersect at exactly 1 point. Just kidding, John. I quit doing that last year because it got me in trouble. No more pictures of students.
Not even pictures, video.
Next one. What's the next one called?
3-point postulate.
3-point postulate. Doesn't have anything to do with basketball. 3-point postulate. We talked about this earlier this year. If I give you 3 points, there's a point, there's a point, there's a point. And they're non-collinear points. What's non-collinear mean again? Not on the same line, all right? So they're not all on one line. 3 points, like I have right there. How many planes in our world contain those 3 points? Exactly 1. The only plane, what would we call the plane in here? Give me the actual name for it. The what? The whiteboard, right? That's the only, this whiteboard right here is the only plane that contains those 3 points. So that's my plane. It's the only plane in the world that contains those 3 points. Somebody name that plane for me. Say it again. T. Now, if I write that, is that correct? You have to write plane out in front. If you're using the 3-letter method, if you're picking 3 points that's on there, you have to write the word plane out in front. Now, Aiden looked at this, and you got to be careful with this. Can I name it just plain T? That T corresponds to a point, right? So you can't name it with just that one. If you see something like this, now how can you name it? Plain O. Does everybody see that O right there doesn't correspond to a point? It's just there just to name that plane. So 2 different ways to name the plane. They give you that special letter in the corner. That's one way. Plain whatever. Or pick 3 letters. What's the name of 2.5?
Plain point postulate.
Plain point postulate. I don't have a picture for this one. Plain point postulate says, at least I don't think I do. If I give you a plane, how many points are there on that plane? At least 3. There's at least 3 points on that plane. Oh, you're writing it down. Just flipped it over already. I'm thinking that you're off in there in the woods. I should have known that. I'm saying that. I should have known that that would happen. So. Just write down something else. I don't been off with the whole world for a minute. Yes, just. Hurry.
So,
Next one, what's it called?
plain line postulate?
Plain line?
Yeah.
Plain line postulate. I'm gonna have somebody come up and you're gonna draw this one for me using this pen. So write it down, I'll give you a second to write it down, sort of think about it for a second. Make sure your binders, start getting them in some kind of order. If you're gonna draw a picture, draw something big so I can't go on my wall. Got a volunteer come up and try to draw it? I don't know, man. I hadn't looked at the book, so I'm not sure.
Look back, right?
About if you just go what it says up there, I mean, if you just start reading it, you know what you need to draw. Go ahead, Brandon. You can handle it. Have faith in it. Use the other. Yep. First thing he's going to draw is his plane. Spectacular start. Now, before we go any farther, let's put a letter in the corner so we can name that plane. In the corner, in the corner. That's right, just leave that there. Yeah, one. It doesn't matter which corner. One of the corners. You were a little far from the corner. All right. Now, does that letter go with the point? No, that's just for the plane. So, what plane did Brandon draw? Plane R. Then, what else is he going to draw next? Got some point. Let's give it a draw the point. Just draw the points. Now you messed it all up. Scratch that out. Draw a point. You're getting ahead of me. Give it a letter so we can name it. What point is that? Point S. Draw another point. Give it a letter so we can name it. Point A. Alright? So we got the plane, we got the 2 points. The 2 points are in his plane R, correct? Now, does everybody understand when it says in the plane? You gotta quit. You can't think about this. This calculator, is it in the plane that's the desk there? It's sort of on the plane, right? Now, we use that a lot. And I'll say, yeah, the calculator is part of that plane because I can't really stick something in the desk and make it actual part of the plane. But that's what in the plane means. In the plane means it's actually on there. I can't grab point A there and pull it off the plane, right? So that's why it says in the plane and not on the plane. What's the next part tell us to do? Draw a line. Puts an arrow on that end, puts an arrow on that end. Somebody name Brandon's line for me. Line SA. Everybody agree with that? Line SA. Line symbol on top, SA, capital letters. That whole line that he drew, is it in his plane R? Is any part of that line going to be in some other plane that he didn't draw? No, it's all going to be in that plane. And that's all this says. Thank you. So if you have 2 points on a plane, then the line that contains those 2 points must be on that plane. Must be contained within that plane completely. Let's skip over my drawing here real quickly because Brandon's drawing so much better. Next one, what's it called?
Plane intersection postulate.
Plane intersection postulate. Plane intersection postulate. Might want to make sure you're listening when you write this stuff down because you probably can't read my cursive. And I forget not to write in cursive. Plane intersection postulate. If I got 2 planes, try to show you this way before I show you my picture up there because it's not very good. If I got 2 planes, they come together and they intersect. What do they intersect at? A line. We talked about that earlier this year too, right? Give me a plane in the room. The whiteboard or the chalkboard? Chalkboard. So we got the chalkboard. Let's actually use the whole wall. All right. So we got that whole wall over here. Give me another plane. This wall. Those 2 walls, they come together. They intersect. What do they intersect at? A line. 2 planes will always intersect at a line. I'm going to walk around here in a minute. Draw the picture for it. I'm going to walk around because I know there's going to be a whole bunch of you laughing at, name that plane for me real quick. Plane B. A whole bunch of you laughing at my drawing. So I'm going to walk around so I can laugh at your drawing. So everybody see my 2 planes? What's the name of that? Clear plane. Plane M. Got it? That's where they intersect. That line. Somebody name that line for me. Line M. I know it's sort of hard to imagine no way, shape, or form in my Mrs. Alexander where I can draw something that actually looks 3-dimensional. Devin's still staring at it. What? What's the dashed or the dotted line on the clear plane tell us? That's supposed to be like it's behind it, right? It went through it, and that part is the part you can't see through the blue plane. Drawing perfect, Colin.
Am I drawing perfect?
Bet Caleb's is.
Whatever.
Caleb's is perfect.
Yeah.
When they do it outside, like in the hallway,
Are they downstairs right there? Is that where they're at there? They like separate. They'll put some of them here, some of them here, so they're not disturbing each other. That doesn't help that they disturb us. Try to draw this picture. Just try to draw something there on your notes real quick.
He's gone. He's like, I'm tired of scratching.
See that more than
No, look at him. So what you do?
yell at him. Knock it off.
Holler.
Shut it.
I know.
so now you can't hear him. Wow, that's good.
You got a line that's perpendicular to a plane. What's the first thing I'm going to draw here?
Plane.
Probably draw the plane first, right? Give me a letter so we can name that plane. M. So I'll put M right there in the corner. So we got plane M. We got a line that's perpendicular to it. What's perpendicular mean again? Intersects at 90 degrees, makes a right angle. So how do I want that line? Do I want it to just be laying on the plane like this? No, what's it got to do? It's going to go through the plane, right? So maybe something like that. How am I going to show that it goes through?
The dotted line.
A little dotted, good. Dotted when it comes out the other side over here. Again, my picture's not very good. You can probably do better. Now, we want to make sure that it's perpendicular. How are we going to, can I just say, oh yeah, that's perpendicular? And just assume it? What do I need in the picture to show that it's perpendicular? What shows you in a picture? If I gave you a picture, if I gave you this angle, what would show you that it's a right angle? Got to have a little box or something there. So I have a little box, maybe something like that, that looks like it's standing on the plane. So this is what my picture's supposed to look like, even though my drawing's not very good. That's our plane. This is our line. It's hitting it like that. That forms a right angle with it. In your books on page 87, page 87, get out a clean sheet of paper. We are going to do this assignment together, and we're going to move extremely quickly because then we got something else we got to do. You are going to hand this in. Rick, you see this desk right here? At the end of the class, that's where everybody's going to put their assignment. So when you see somebody putting it somewhere else, tell them they're doing it wrong, all right?
Hey, do we have a game Saturday? No. This isn't our homework, is it?
No, this is your homework. We're going to turn this in before you leave. So you're actually going to do two things today. This should be a free grade because we're going to go through it and do it together. I know none of you need a free grade, right? Brandon, you don't need a free grade, do you? Which questions?
Is there any
You probably just want to do the first one, then you might need some space. We're going to do them together, so we're going to move. Has everybody got the assignment written down? We can still hear them.
Hard to myself.
Yeah, this door's open. Got it now? Thank you, Aiden. That was what I was thinking, but
Alright.
what do you say? How about now?
Yeah.
Number three, they give you this picture, says if. What's in the hypothesis part of the statement here? What do we have? 2 points, right? 2 points. If this, then that. They want to know which postulate they're showing you in that picture there. Which postulate is it? What's the postulate say? Don't tell me all this, just tell me the postulate. We just went over them. 2 points. It's a 2-point postulate. Tell me what it says. 2 points make one
Should we just write whatever you write?
line. Yep. That's your answer. 2 points. What do we know about 2 points? Any 2 points make exactly
One line.
one line. Good. Be careful on the next one. What are we starting off with on the next one? Starting off with a plane, right? So if we have a plane, then what do we know?
Plane.
What's the other one?
Plane intersection.
If you have a plane,
Plane line postulates.
don't give me a name because I don't know what they say. If you have a plane,
Oh, plane
then you know you have what?
At least 3 non-collinear.
Okay, so then at least, and I'm just gonna shorten it up, at least 3 points. So if you have a plane, then you know you have at least 3 points. We don't use that one very much. The one that we do use all the time is if I give you 3 points, then you know you have a what? Plane. Next one, number 5. Somebody help me out. What's the directions for 5 through 8 say?
Use the diagram to write an example of the postulate.
So we want to write an example, something in here for each one of these. Line point postulate. What's the line point postulate say again?
Through any three non-collinear points, there exists exactly one plane. Oh wait, no, wrong one.
A line contains at least 2 points, Ricky said. Does everybody agree with that? Name me a line in this picture. Line JK. Line JK. Make sure you're naming this right. You got your symbol, the 2 letters above. Line JK contains what 2 points? Points J and K. Any line must contain at least 2 points. Line intersection postulate, what's it say? So you got 2 lines that intersect, they intersect at exactly 1 point. Do we have 2 lines in this picture that intersect?
Yep.
Name one of those lines for me. Line. You had to make it harder on me because I'd already drawn the symbol, didn't you? Line P. Is it all right to name that line P? Give me another line. Line Q. Line with the word Q. Lowercase letters. Different than naming it that way. Got to know both ways to name a line. Line P and line Q intersect at, Abigail, can you read that? Probably not. Because you're listening instead of looking at my writing, right? Because you can't read it. Intersect at what point? Point H. I try to remember not to write in cursive, but you can see it's not working very well today. What's the 3-point postulate say?
Through any 3 non-collinear points, there exists exactly 1 point.
So we got our plane right here. Give me 3 non-collinear points that we could use to show that plane. K, L, G. That's good enough for the answer on this one. Those 3 points make up that plane. K, L, and G. Could you put a different answer than that one? Yeah. I think I wrote this one wrong because I don't think there is a point line postulate. It's a plane line postulate, I think, isn't it? Yeah. Plane line postulate. What's the plane line postulate say?
If 2 points are in a plane, then the line containing them are in the.
Give me 2 points in this plane.
Okay.
L and K. The point L and K. Are they in the plane? Are they in this plane? Yes, no, maybe? Yeah, plane what?
In.
If L and K are in that plane, then what do we know? Line LK is in the plane. Now, a lot of you are acting a little confused right now because you're saying there is no line LK. Is there a line LK?
It's not drawn.
It's not drawn. Could we draw it if we wanted? Is it all in that purple plane that I have right there? Yeah. Next one, sketch each. I don't have a whole lot of space, so my pictures aren't going to be very good. Number 9, plane P and line M intersecting at a 90-degree angle. We just sort of got done doing that, didn't we, on that other picture? So what am I going to draw first? Draw a plane. What letter am I going to put up here in the corner? P, because that's what they said, plane P, right? Now we want line M to intersect it at a right angle. How are you going to draw that? Draw a line, just draw it like that. Can I just draw it on there like that?
No, you got
It's going to go how and through the plane, right? So you're going to do something like maybe this, dotted, and then it comes down here. What are we going to put right here? Put that little box. We want to name that line, line M. Do I put M right there at that point? Where does the little m go? On one of the 2 arrows, little m, a lowercase m. Somebody read this one to me.
Segment XY in plane P.
So let's stop right there. What's the first thing I'm going to draw then? Plane P. What else we're going to draw?
Segment XY.
Some segment, XY. So what do I put right here on this point? X. On this point? Y. Now let's go on. What's the rest of it say?
Segment XY bisected at point A.
So let's stop right there for a second. So it's bisected at point A. What's bisected mean? Split in half. So where am I going to put A? Like right here? Right at the center of that segment. Put point A right there. Now I need to show that those two are the same so that when Devin looks at it next time, he knows it. So I'll put little tick marks on those. Now let's go on. What's the rest of it say?
And point C not on segment XY.
So point C is not on XY. So where am I going to put it? Somewhere not on XY. So put another point on here somewhere. Label it C. What am I going to start off drawing on the next one? Segment XY, right? This one doesn't have a plane. So segment XY, we draw some segment, maybe it looks like that, XY. Then what's it tell us? So it intersects segment WB. So am I going to draw WB like up here somewhere? Where are you going to draw? Intersecting. You might want to read a little more to make sure they don't give us some other information about how it intersects and then we mess it up, right? So what's it? Does it tell us anything about how they intersect? At point A, doesn't really say that they bisect each other or nothing like that, right? So we could just draw it anywhere. Maybe something like that. What's this point right here in the middle going to be? A. What's this point up here? W. How about this point? B. Now they do tell us one other thing. What's this last part say?
Segment XA is congruent to B.
How am I going to show that? Put those little tick marks, right? So this is segment XA, and it's congruent to segment VA. Where's VA at? Left, right, top, or bottom? Bottom. It's right here, right? Is point A bisecting those? No, because it's these two are congruent, not the two that are splitting up, right? Next one. Take all points off my teaching score today, Michael, because I forgot my segment symbols there. Segment AB, segment CD, segment EF are all in plane P. What's the first thing we're going to draw? Draw plane P. Mine's not going to look very well because I don't have a whole lot of room here. Got plane P, put P in the corner somewhere. Point X is the midpoint of all 3 segments. So we're going to draw these 3 segments. I'm doing this one pretty quickly. We got that right there. Point X is in the middle. What am I going to call this first segment? What's the two endpoints? A and B. Second one, C, D. Third one, E, F. What do I know about segment AX and segment XB? They're congruent. Now, do I know that all 6 of those little segments are congruent? Did they tell us that? No. So I know those 2 are congruent. I know those 2 are congruent, so I need to mark them different. And you can't hardly see it on mine. So I'm going to put 2 tick marks on those other ones. Then I'm going to put 3 tick marks on the last pairs. Sort of hard to see. I'll redraw that up here so it looks a little better. Make it a little bigger. This is what it should look like. Those 2 are congruent. Those 2 are congruent. Those 2 are congruent. And stick the letters in there. Next one, can you assume? We're going to tell whether we can assume it from the picture or not. Planes W and X intersect at line KL. Is that what the picture looks like? Does everybody see the clear plane and the blue plane and how they sort of go through each other? Sort of hard to tell. Again, my drawings aren't the greatest. You might be better off looking at the book. Those 2 planes intersect each other at line KL. Yeah. So we can get that from the drawing. Points K, L, M, and N are coplanar. What's coplanar mean again? Same plane. K is actually on both planes, isn't it? L, which plane is L on? It's on both also. M, which plane is M on? Looks like it's on the blue one, right? Because it's sort of behind. N, which plane is it on? The blue one also. Are all those points coplanar? Yeah. They're all on the blue plane. Now, L and K are actually on the clear plane also. Points K, J, and M are collinear. What's collinear mean again? Same line. K, J, and M. Or Q, J, and M, sorry. Is that true? No, so we can't decide that. There might be some line, depending on how those planes are, but we can't tell it from the picture. Line MN and line RP intersect. MN, that's this line. It's supposed to be dotted there. And RP, it's this line. Do they intersect? They go like this, don't they? One of them, the one comes this way, the other one comes like behind it back here. Looks like they cross each other, but do they ever touch? So we can't decide that from the picture, so it's no. JK lies in plane X. Plane X is the blue plane. Does line JK lie in that plane?
Yes.
Yeah, as a matter of fact, JK is in both planes. Angle PLK is a right angle. PLK. PLK. We can't decide, right? And that's what I would write here. Can't tell. It might be a right angle, but we don't know for sure. What would tell us for sure that it's a right angle? If they put that little box right in there. Angle NKL and angle JKM are vertical angles. JKM is right here. NKL is right here. Are they vertical angles? You got to sort of be careful with that, because can you really have vertical angles when you're doing a three-dimensional picture like that? Yeah, but not something we can talk about, so I'm gonna put can't tell on that one for sure either. Gotta be careful with vertical angles. Angle NKJ, NKJ, that's this angle right here. And angle JKM, it's this angle. Are supplementary. What's it mean to be supplementary again?
Add up to one.
Do those two add up to that straight angle there? Yeah, so that answer is yes. 20 is yes. We're gonna skip 23. 27. If and then statements. We got that statement. Through any 2 points, there's exactly one line. Let's write it as an if and then statement.
If there are 2 points, then there is exactly one.
2 points, then exactly one line. That's the first part of your answer. Converse. What's the converse do to it?
If one line, then 2 points.
Switches the hypothesis and the conclusion. That's your hypothesis. That's your conclusion. So say it one more time.
If one line, then 2 points.
If one line, then 2 points. Again, Michael's gonna make sure that his grammar and stuff is actually better than that on a test, right? I'm trying to go fast here. Inverse. What's the inverse do to a statement?
If not hypothesis, then if not conclusion.
So if not, you leave it in the original order. So if, not what? Or if, doesn't have to be not necessarily.
How many points does that one say? The converse, I think, something. Then 2 points.
Sorry. I forgot my 2. So what's this one gonna say? If not 2 points, then what? Then not one line. Now again, that doesn't make much sense. You probably want it to make better grammatical sense than that and say, if you do not have 2 points, then you do not have exactly one line. What's the contrapositive do to a statement? Switches and negates. So what's it gonna say?
If not one line, then not 2 points.
If not one line, then not 2 points. Get all that, Michael?
It also says we're supposed to state whether it's true or false.
So we're supposed to tell if it's true or false? The original statement. You got 2 points, you got exactly one line. Is that true or false?
True.
True. If you have one line, then you have 2 points. True or false? True. If you don't have 2 points, then you don't have exactly one line. True or false? True. If you don't have a line, if you don't have one line, then you don't have 2 points.
That's false.
That does sort of seem false, doesn't it?
Aren't the first and last?
But the first and last one are usually true. If the first one's true, then the last one's usually true. On these, what property would you use to solve this? What do you do to solve this equation? Don't write this down. We're going to skip over these 4 real quick. Just tell me the property. What would you do to solve it?
Oh,
Add 6. So guess what property you're using? Addition property of equality. What would you do on this one? Division property of equality. How about on this one? Subtraction property of equality. Multiplication property of equality. Set that off to the side. Make sure your name's on because you're going to turn it in. These are your notes. We got like 7, maybe 8 properties to write down. Write these real quickly. Add them to notes that we did earlier today. Levi back here, he's like Mr. Artist drawing those plans. Wish he'd write bigger so I could read his writing. Again, if you haven't yet, if your parents haven't emailed me back, that's the bonus stuff you set off the side somewhere else. If your parents haven't emailed me back yet, have them do it so you can get the bonus points. Unless you don't need the bonus points, because your grade's so spectacular. Yours is spectacular. Dad have an email?
Check it.
You could tell him to check it.
I think that's good.
Huh?
I think that's good.
Wouldn't that be easier than me calling him? I'll call him. I was trying to make it easier on all of us. When you're writing these, I probably should have said this a minute ago, these are algebraic properties. I would abbreviate. I wrote it down here. So instead of writing out addition property of equality, this is what I would write. Add prop of equals. That's good enough. I'll know what you mean. Now the one that you can't really do that with is subtraction. So subtraction, you need to write it out. At least write out the word subtraction. The property and of equality, you could abbreviate that. Crawling around in the wall. Multiplication property, you could abbreviate it. Something like that. Division property, same thing, it could be abbreviated. Everybody got this much? Sorry, that was a sticker. Now? Yes? Ah, went the wrong way. Next one. Don't put everything up. We got a bunch of time yet. 6 minutes. Substitution property. This is the reason that you can't abbreviate subtraction property. Substitution property. Do not abbreviate it either. Write it out so I can tell the difference between substitution and subtraction. Otherwise, I won't ask. I'll just mark it wrong. Substitution property. All it says, you can take out one thing and put something of equal value in its place. You've been doing substitution property since you were in first grade. You just didn't know it. You had this problem in first grade. And they gave you the little blank down there. And you said 5 plus 3 and you wrote down what? 8. You got rid of the 5 plus 3 and you substituted 8 in its place. That's all substitution property is. So anytime you're collecting like terms or combining like terms, when you combine like terms, write down your reason as substitution property. Anytime you're just adding or subtracting, you're using substitution property. If you're just multiplying, if I ask you what's 5 times 4, and you tell me what? 20. We took out the 5 times 4 and we replaced it with 20. Distributed property. Everybody seems to know distributed property. Probably because Caitlin likes to draw the little arrows. It's fun for her or something, so she remembers it. I don't know why, but everybody always remembers distributed property.
It's easy, is that what it is? I never did that.
Everybody got that much? Close now? Yeah? 3 more properties. Put a big asterisk beside this one. Reflexive property. You probably learned reflexive property in algebra, but you didn't talk about it a whole lot. So you might have talked about it for a minute and then skipped it. Reflexive property says anything equals itself. Reflexive property, very, very, very important in geometry. So when I look at Joe, I can say Joe equals what? Joe. That's all the reflexive property says. Angle Q is congruent to what angle? Angle Q. Anything equals itself. Symmetric property. The way I remember symmetric property and what you do, what's symmetric property start with? S. Guess what else starts with S? Switched. That's all you're doing with symmetric property. You used symmetric property a whole bunch last year, probably didn't even know you were doing it. You were solving a problem, you got down to the bottom and it said this. And then you wrote down your answer. What did you write down? X equals 5. You turned it around, you switched it. That's you use symmetric property. Symmetric property just says you can take an equation and turn it around and it doesn't change anything. Transitive property. Everybody usually remembers transitive property. If I tell you X equals Y and Y equals Z, then we know X has to equal Z. That's the transitive property. How close, Brandon? One more. Quick one. Got it, Brandon? Yes, no, maybe? Sure. I'm not trying to rush you. I mean, I am trying to rush you, but I want to make sure you have it. 2-column proofs. This is what a 2-column proof looks like. Statements, reasons. Each statement has a number. Each reason has a number. This is what part of what you're going to do on your homework. So you have a 2-column proof. You got a statement, you got a reason column. Normally your first reason here is going to be given. Normally, not always. Should always be, but on the EOC test last year it wasn't always. They put one on there where it didn't have any given information. Everybody sort of got that? Assignments, page 96. Make sure you're going to lay that paper. Caitlin just put it away. Lay that paper that we did in class right there on that desk. Don't walk out with it. The test redo. If you didn't put it in this file, I will accept it come next week, 1 extra day, because I still got people taking the test. So the test redo, if you haven't done it yet and you need those points, get it into me. Have a great day. Have a good weekend. Maverick, we lay that over there with you. Thank you, sir.
You're great friend, I know.
Joe, get in a better mood. I'm going to have you come in here a little looking all sour pussy like that.
Had to remind myself.
How you doing, Mr. Everson?
Good.
Yeah,
Did I give you a copy of that? I mean, that's kind of let's start with this. Not too much other than that was part of my problem. After you take the test, you got enough other stuff that you need to get caught up on. You'll be fine. You're fairly. Yeah. Hurry.
Might have to pass a picture. Oh, yeah, I got excellent. Oh, what?